Alright, so in this video we're going to talk about property 3 in your textbook. I'm going to refer to it as a quotient property for radicals, and that's going to allow us to do problems 11 through 14. So in question 11, we're asked to simplify the square root of 2a divided by 9. In 12, it's now a cube root, so you're looking for perfect cubes of a fraction. In 13, we'll do a problem similar to 13. We're going to be using that product property in a different direction. And in 14, again, cube rooting of a fraction, so I'm looking for perfect cubes. All right, let's go ahead and talk about this property. All right, so my quotient property here, the nth root of a fraction is a quotient, is the nth root of a divided by the nth root of b. There is no side to equalities, so it's good to be able to go both ways. Okay, so now let's do a problem similar to problem number. All right, so this is similar to 11. How about the fourth root of 16x all over 81. Using this quotient property, that's the fourth root of 16x divided by the fourth root of 81. Now 16 happens to be a perfect power of 4. 16 is 2 to the fourth. Let's see it. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. '81 is also a perfect power of 4. 81 is 3 to the fourth. 3 times 3 is 9, times another 9 is 81. Okay, right on this next step, I'm really taking advantage of my product property because x is not a perfect power of 4. But the fourth root of 16 is 2 because 2 to the fourth is 16, and the fourth root of 81 is 3 because 3 to the fourth is 81. Okay, and done. All right, I would now like to do a problem that's similar to questions 12 and 13. In 12 and 13, we're both taking roots of a fraction that have variables in them, right? And so the game with each of them, like in 12, because I'm looking at cube roots, I'm looking for perfect cubes that can be taken out of the numerator and the denominator. In 14 also happens to be a cube root. I'm looking for perfect cubes that I can take out of the numerator and the denominator. I don't want to do those exact ones. I'm going to leave them to you, but we're going to do something similar together. All right, so in this problem, I've chosen to do a square root. Make sure you pay attention to that. If it's a cube root, you're looking for perfect cubes. If it's a fourth root, you're looking for perfect fours, but I've chosen to do a square root. And I can use my quotient property, and take the square root of my numerator and take the square root of my denominator separately. One thing that I see right away is that my denominator happens to be a perfect square. The square root of 16 is 4. That's nice. Now in my numerator, I'm going to get ready to use my product property, and the game that I'm playing, again, is looking for perfect squares because I'm taking a square root. Perfect square factors, numbers that divide unevenly here. So 50 is a 25 times 2, right? 25 is a perfect square. And x to the fourth is a perfect square as well. It's x squared squared. But what you could do is you could just write x to the fourth as x squared times x squared. And then y to the fifth has a y squared times a y squared times one more y in it, all over 4. And now using my product property, I've got the square root of 25. Let's just even pull all my greens out. Square root of 25. Yeah. Square root of x squared. Square root of x squared. Square root of y squared. Square root of y squared. And then we have some stuff underneath that radical. Maybe I need more color. Oops. And then what's left over underneath the square root that wasn't a perfect square? The 2 and the y. All over 4. Square root of 25 is 5. Square root of x squared is x. Square root of x squared is x. Square root of y squared is y. Square root of y squared is y. 2 root y. And then just simplifying here, x times x is x squared, y times y is y squared. Square root of 2y we leave alone because there's no more perfect squares there, all over 4. And we are done. Okay. And now I would like to do, in conclusion, I would like to do a problem like number 13 here. We're going to use different numbers, but we're going to use that that quotient property in a little bit different way. So let's do a problem similar to question 13. All right, so this is similar to question 13. So it looks like there's kind of nothing to do here right off the bat because there is no perfect square except for one. You know, 2 squared is 4. 4 doesn't go in evenly to 21. 3 squared is 9. 9 doesn't go in evenly to 21, etc. 4 squared is 16. Right? These don't divide into 21. Right? And so, like, what is there to do here? Well, I'm going to use this quotient property. There is no side to equalities. So far we've been saying the square root or the nth root, the cube root, etc. The nth root of a fraction, well, we get to take the root of the numerator and divide it by the root of the denominator. But let's now go the other way. Here, I'm taking the square root of the numerator and the square root of the denominator. Since the root is the same, they're both square roots. This is the square root of 21 divided by 3, and that's a fraction that I can simplify. 21 divided by 3 is 7. Here we have it, answer square root of 7. That's simpler. I'm done. Oops. But don't write in the highlighter. All right, so that concludes our video. Thank you for watching.